Hello learner, welcome to this lesson, Algebra Part 2. First of all, let's look at the addition and subtraction of like terms. Like terms have the same variable. We've learned what variables are in the first video. So we are therefore saying here that like terms have the same variable. Addition and subtraction of like terms. Let's look at what like terms are. Like terms, they have the same variable. So like terms have the same variable. Then if there is a power, an index or exponent, it means that they will all be raised to that same power. The difference only comes in the coefficients. You know what these variables, these terms, these exponents or power or the coefficients are. If this still confuses you, then I recommend that you go back and watch the part 1 of this video. I'll leave a link in the comment section. Now, how do we add or subtract like terms? It is important to know that you have to keep the variable parts the same as it is. Do not change it. Then add or subtract the coefficients. So basically, the coefficients is where our interest is going to be. So let's take the first example. Example number 1. If we have 4x plus 8x, we can all see in this expression that the x is the variable. The coefficients are 4 and 8. What we need to do is to add the 4 to the 8, 4 to the 8, and then that gives us 12. So we'll have 12x. We take the second example. Example number 2. We can have 13y minus 7y. This is equal to, this is just like 13 minus 7. You can write it as 13 minus 7. And what is 13 minus 7? If we are given 13 mangoes or whatever, and then we are asked to take 7 out of it, what is the remaining? It means it will remain 6y. 18m plus 3m plus, let's say, maybe 9m. What is this going to give us? We can add 18 plus 3, making it 21. Then 21 plus 9 equal to what? 30. Then we add the m to it. Therefore, we have 30m, and that is the answer. So anytime you're asked to either add or subtract expressions that are like terms, this is a very simple way you handle it. Also, let's look at when there are unlike terms. You are dealing with terms that are not like terms. So in this particular question, say you are given, let's say, you are given 10x plus 5y minus 2x, let's say, plus 3y. How do you solve this kind of expression? So it is not just only unlike terms, but there are some like terms in it. If you follow the lesson, you clearly see that there are two variables. The first variable is x, and the second variable is y. We have 4 terms. The first term, second term, third term, and the fourth term. So you can see clearly that the first term and then the third term are like terms. Likewise, the second term is also a like term to the fourth term. So let us try to write them, bringing the terms that are like close to each other. That is, if we are writing our solution, we have our 10x minus 2x. They are like terms, plus 5y plus 3y. 10x minus 2 is just like 10 minus 2, or 2 from 10. What does this give us? It gives us 8x plus 5y plus 3y. It's the same as 5 plus 3, also giving us 8y. Now, finally, you see that these two terms are not like terms. Therefore, we can't do anything to them. You leave it as it is. Here is yet another question that we need to find solution to. The solution to this is, look at the question first. Let's study it. This question, if we look at it very well, it has a number of variables. We have variable P, variable Q, variable R, variable P, S, and Q. You see that some of them have been repeated. P has been repeated here. The variable Q has been repeated here. And I think that is all that we have. Having this, it means that those that have been repeated, those repeated variables are like terms. They are the like terms. So we can clearly say that 6p and negative 2p are like terms. Likewise, negative 2q is also a like term with 6q. So let's write these close to each other. With this, we will write 6p minus 2p minus 2q plus 6q plus 4r plus 3x. It means you have brought all the terms together. Let me do this so that you understand. This and this are like terms. This and that is also like terms. These two are unlike terms. Therefore, 6 minus 2, see them to be 6 minus 2, negative 2 plus 6. That you get the answer very fast. 6 minus 2 is 4p. The negative 2 from 6, or negative 2 plus 6 is all the same thing. It gives us positive 4q. We have 4r. There's nothing to add or subtract from it, so repeat it. Then we also have s. The coefficient of x is 3. There's nothing to add or subtract, so we repeat it as it is. So this is one way of dealing with questions that are having unlike terms. Here's another question on the board that we need to find solution to. Let's study the question first. This is 3x squared plus 6yxy minus 3y squared plus 4x squared minus 8xy plus 2y squared. The most important thing here is to identify those that are like terms. You see we have the variable x squared here. We also have another x squared here. So these two are like terms. We have xy, the variable xy here. We also have another xy here. It means, therefore, we can conclude that these two are equally like terms. Finally, we have y squared here and also y squared here. They are also like terms. So let's bring the like terms closer. We are going to write 3x squared. The next like term is 4x squared. Then we take 6xy. It is also a like term to negative 8xy. Then we have minus 3y squared plus 2y squared. Now, like we did before, 3 plus 4, 6 minus 8, negative 3 plus 2. That is what we are going to do. So you see that 3 plus 4 is 7. Then we add the variable, which is x squared. We don't touch it. Then, 6 minus 8 is negative 2. Then the variable is xy. Also, we have negative 3 plus 2. Negative 3 plus 2, or 2 from negative 3. It gives us negative is 1. The coefficient here is going to be 1. Once it's 1, you don't write it. So, we write our y square, only the variable. We have three terms, 7x squared minus 2xy minus y squared. We can't do anything to these because they are not like terms. We can't do anything. This is x squared, this is xy, and this is y squared. They are not like terms. So finally, your answer is 7x squared minus 2xy minus y squared. Please do follow for the part